good afternoon to everyone. Today, I like to discuss about the charging of LCR circuit, a circuit which consists of capacitor along with inductor and resistance with a source. So, in this diagram, here this one is L, that is inductor, then C is a capacitor, and here R is the resistance. And this is the key, and this key point is third point, which is connected to 1, and 1 has a source voltage V. 1 is a source voltage V. So whenever we connect 3 to 1, this is two-way key. Two-way key. So when key third is connected to 1, then this is a closed circuit. And in this closed circuit, a current starts out flowing. This is IT. A current starts out flowing. So we have the inductor L, capacitor C, and resistance R with a source voltage V in the two ways keys as shown in the figure. As shown in the figure. So what we have when key point 3 is connected to 1. 3 is connected to 1, then this case is charging. This case is charging. And when key point 3 is connected to 2, then this is discharging. This is discharging. So this case, that is discharging case, has been discussed earlier. और इसमें जो कैपेसिटर फुली चार्ज्ड है वो किस तरह से डिस्चार्ज होगा उसको डिस्कस किया जा चुका है. आज हम केस फर्स्ट के बारे में डिस्कस करेंगे. व्हेन 3 इज कनेक्टेड टू 1, दैट इज द चार्जिंग ऑफ ए कैपेसिटर थ्रू L and R. So the potential drop across the passive components L, C and R are given as across the inductor, the potential drop is L, and this potential drop L is L di by dt. L di by dt. Second, capacitor VC is equal to Q by C. VC is equal to Q by C. And across the resistance, VR is equal to IR. VR is equal to IR. So these are the components. That is BL. BL is equal to L di by dt. This BC. BC is equal to Q by C. And then this is VR. VR is equal to I into R. These are the components along the circuit. These are the components along the circuit. And these voltage drop can be algebraically expressed with the help of Kirchhoff Voltage Law. You know, applying Kirchhoff's voltage law, in the circuit, we have BL plus BC plus VR minus B is equal to 0. How this is happened? We have this, when current is flowing in this way, so this point is positive. This point is positive. So this BL is positive. This voltage across the L is positive. And this is negative. This is negative. The other end of the inductor. Now this plate of capacitor is positively charged. This is positively charged, and here this is negative charge. And this point is positive, and here it is negative. Here it is negative. This is the positive voltage, and here it is the negative voltage across the resistance. So this way, what we have, this is the state of capacitor. This is charged with the help of the source. Source, that is when we connect point C to 1, then this one is the start of charging. This one is the start of charging, and due to this charging state, the energy in the source, is stored in the electrical energy. We have what we have, that is the energy is in the form of electrical energy across the capacitor, and this energy, that is this capacitor stores the electrical energy, and this inductor stores the magnetic energy. And this resistance is not storing the energy, but it is dissipating the energy. This is the dissipating the energy. And so the source, which has the potential V, is the source of energy, and it is current flowing in this way. So due to this current, here it is the magnetic energy stored across L is in the form of magnetic energy. Then this capacitor stored the electrical energy, and this resistance is loss medium, that is dissipating the energy. These two are storing and this one is dissipating the energy when the point 3 is connected to 1 in this circuit. So, in this circuit what we have, consider the inductor L, capacitor C and resistance R with a source voltage V. This is the source voltage V that supply the energy, and that energy is stored in the form of magnetic energy in L and electrical energy across the capacitor. So, due to the flow of current, there is the potential develop across, and basically this is the transient phenomena. So, what transient phenomena is? This transient phenomena is, here it is the time, and if it is charge T or current T or voltage T, so this will grow something. So, this part is the transient state, and this transient state has to be discussed. Transient state that has to be discussed, and as I have said, this is the passive component and this the passive component. In case of active component, the value of transient, this tau is T on, time on is equal to approximately 50 nanosecond, and this is tau off, that is time off is approximately 70 nanosecond in case of the active component. In case of active component like transistor, FET, ICs, so these are the active component time. But in case of the electrical circuit, it is in the order of millisecond, in the millisecond state of this one is. So what we have to do, we have to generate a differential equation, and for this differential equation we use this potential equation which is obtained on the basis of the Kirchhoff Voltage Law. So by substituting the different values in the Kirchhoff Voltage Law, then we have the expression something like this. We have the expression something like this is L di by dt, that is the expression for the voltage across L, then this is Q by C, then I R minus Vc is equal to 0, or this equation can be written as di by dt plus R by L I plus Q by LC minus V is equal to 0, or we know I is equal to dq by dt. I is known as dq by dt, and di by dt, that is d of dt into dq by dt. So this is d2q upon dt square, d2q upon dt square. So what we have? We have d2q upon dt square from this expression plus R by L dq by dt plus q by LC minus V is equal to 0. This is equal to 0. So we can also express d2q by dt square plus R by L is supposed to be 2b dq by dt plus 1 by LC. If you take common, then q upon Q minus V, this is V and here it is V LC is equal to 0. This is 0. So this is dq by dt square plus 2b dq by dt plus omega square, and this is q, and this q is equal to 0, or we can say q minus q0. That is q0 is equal to V into C. V into C, that is original part. If we put this x is equal to q minus q0, then dx by dt is equal to dq by dt and d2x by dt square is equal to d2q by dt square. So if we substitute this value in this expression, this can be termed as, this is equation number 1, this is the equation number 1, then this is equation number 2, this one is equation number 3, and here it is equation number 4. And by substituting this value in the equation, so we have this equation is as, d2x by dt square plus 2b dx by dt plus omega square x is equal to 0. So this is the standard second order differential equation, standard second order differential equation. And the method of solution. The method of solution is as usual, you know, in case of the whole process is as the case of discharging. The whole process is the case of discharging. So it is up to you, that is a part of your homework, that you have to find out the solution on the basis of discharging. I have just giving the concept, that is, let the solution is x is equal to a raised to the power alpha t. So dx by dt is equal to a alpha e raised to the power alpha t, and d2x by dt square is equal to a alpha square e raised to the power alpha t. So substituting the value of x, dx by dt and d2x by dt in above equation, so we have a alpha square e raised to the power alpha t plus 2b a alpha e raised to the power alpha t plus omega square a e raised to the power alpha, this alpha t. So we take common e raised to the power alpha t, so it is alpha square plus 2b plus omega square is equal to 0. So this is equation 4, here it is equation 5, and this one is equation 6. Since we assume this one x is equal to a raised to the power alpha t, so this value is not equal to 0, and we have this multiplication of a e raised to the power alpha t, and with this bracket is equal to 0, then one of the factor must be 0. So this is alpha square plus 2b plus omega square is equal to 0. This is the second order quadratic equation, and the solution alpha is equal to minus b plus minus b square minus omega square, b square minus omega square. So this one is the solution alpha, and then what we solution x is equal to a
e raised to the power alpha 1 t plus b e raised to the power alpha 2 t. Alpha 1 and alpha 2 is minus b plus under root b square minus omega square alpha 1, and alpha 2 is minus b minus 2 under root b square minus omega square, and then from this we have to find out the constants a and b. So, this derivation is the fourth time derivation. That is, first we have done in the damped oscillation, then forced oscillation, then charging, discharging of this, and this is charging. और एक और इस तरह का आएगा, वो होगा गैल्वोमीटर. तो आज का लेक्चर बस इतना ही. फॉर्मेशन ऑफ दिस इक्वेशन, रूट, एंड नेक्स्ट टाइम इसके आगे हम लोग बात करेंगे. थैंक यू.